Somewhere in the constellation Sagittarius, on June 2nd, 2011, a single star did something strange. It began to brighten, slowly at first, then dramatically, reaching 30 times its normal luminosity before fading back, over weeks, to exactly where it started, symmetrical, clean, as if nothing had happened. But something had passed between that star and us, something we could not see, something we still cannot see. That something was a black hole, not orbiting a star, not feeding on a companion, not attached to anything, just moving, alone, through the galaxy at 100,000 miles per hour, bending the fabric of space around it as it went, leaving the only evidence it could, a temporary distortion in the light of a star 5,000 light-years away. We almost missed it entirely. Here is what you need to understand. Astronomers estimate there are 100 million of these objects wandering the Milky Way right now. Each one is the collapsed remnant of a dead star, many times the mass of our sun, compressed to something the size of a city. They emit no light, they make no sound, they leave no trail. And before 2022, we had confirmed the existence of exactly 0 of them. In this video, we're going to expose 3 things: how the first rogue black hole was finally caught, and what it took; how these objects are born and launched across the galaxy, and what that violence means for everything in their path; and what actually happens when one comes close to a solar system, and why. By the time you would know it was coming, it might already be too late. The galaxy has been hiding something, and we just found out how many. For 50 years, every black hole we found had a companion, a star orbiting in lockstep, its behavior betraying the presence of something dark and massive beside it. That was the assumption woven into 50 years of discovery. Black holes announce themselves through what they do to the things around them. You cannot see the black hole, but you can see the star dancing with an invisible partner, and that is enough. But what if the black hole had no partner? What if it was completely alone? That was the question 2 sky surveys were inadvertently trying to answer when they flagged something unusual in June 2011. The optical gravitational lensing experiment, based in Chile, and the microlensing observations and astrophysics survey in New Zealand were both monitoring millions of stars every night, scanning for the telltale brightening that occurs when a massive object drifts in front of a distant star, an event called microlensing. On June 2nd, 2011, both surveys independently detected the same anomaly, a star in Sagittarius beginning to brighten. The event lasted 270 days. At its peak, the star was 30 times more luminous than normal. And when it faded cleanly, a perfectly shaped light curve that matched the gravitational signature of something very massive passing in front of it. The problem was what was not there. When a foreground star causes a microlensing event, it also contributes its own light to the signal, creating a subtle color change in what astronomers observe. No color change appeared. The lens had no light. It was dark. Kailash Sahu at the Space Telescope Science Institute led a team that pointed the Hubble Space Telescope at the event within weeks of its detection, and returned to observe it 8 separate times over the next 6 years. What they found was extraordinary. The background star's apparent position in the sky had shifted, not by much, not by anything visible to the naked eye, but by approximately 5 milliards seconds, an amount roughly equivalent to the apparent size of a US quarter as seen from over 1,000 kilometers away. That shift, measured with instruments operating near the limit of Hubble's capability, revealed the mass of what had caused it, 7.1 times the mass of our Sun, located approximately 5,150 light-years away. Published in the Astrophysical Journal in 2022, and independently confirmed by a second team led by Casey Lamb and Jessica Liu at the University of California, Berkeley, the discovery was historic. David Bennett at NASA's Goddard Space Flight Center, a co-author on the study, put it plainly: All the black holes that have been found before have been found because they are not isolated. This one was. And here's the implication that lingers. It took 2 independent sky surveys to catch the initial signal, 6 years of patient Hubble observation to confirm it, and measurement precision at the very edge of what our best space telescope can do. If the alignment had been slightly different, the signal slightly weaker, or the survey slightly less attentive, this object would have passed through undetected. It was, by the time we confirmed its existence in 2022, already long gone. If there are 100 million of these objects wandering the galaxy, and that is the current estimate, we have confirmed exactly 1. The rest are still out there, and we have no idea where. So where did it come from? That's where the physics gets unsettling, in a way that goes beyond any single detection. Because this black hole didn't just form, it was launched. We used to assume that black holes, once formed, stayed roughly where their progenitor stars had been. A star lives in a region of the galaxy, exhausts its fuel, collapses under its own gravity, and what remains settles into that general neighborhood. That was the intuitive picture. It is wrong. When Sahu's team calculated the speed of the newly confirmed rogue, they found it moving at approximately 45 kilometers per second relative to its surrounding stars, roughly 100,000 miles per hour. That is significantly faster than almost every other object in its region of the galaxy. And it is not moving toward anything. It is not orbiting anything. It is simply traveling in a direction nothing put it toward, at a speed nothing gradual could explain. The explanation is violent by necessity. When a star, at least 20 times the mass of our Sun, exhausts its nuclear fuel, it dies in a core collapse supernova, one of the most energetic events in the universe. The outer layers of the star are blasted outward, and the core implodes. These explosions are not perfectly symmetrical. They cannot be. The dying star is chaotic, turbulent, and asymmetric in the final moments of collapse. And when the explosion is uneven, the resulting black hole receives what physicists call a natal kick, a literal rocket launch from the asymmetry of its own birth explosion. This black hole, Sahu's team found, may have received its kick as many as 100 million years ago. Since then, it has been moving through the galaxy in a straight line, bound to nothing, answerable to nothing, heading toward nothing in particular. NASA's description is deliberately stark. The self-detonation is not perfectly symmetrical, and the black hole goes careening through the galaxy like a blasted cannonball. Think about what that means at scale. There are an estimated 100 million isolated stellar mass black holes in the Milky Way. Each of them was born from a star that died. Each of them received some version of a natal kick. Each of them has been moving for millions or hundreds of millions of years in whatever direction the violence of their birth sent them. They are not clustered. They are not organized. They are distributed across a galaxy of 100 billion stars, moving in every direction, at speeds no spacecraft we have ever built could match, invisible to every instrument that does not happen to catch them, crossing exactly the right star at exactly the right moment. The first one we confirmed took 6 years of Hubble observations to verify. The rest are still moving, and astronomers are not searching randomly anymore. They have a method, and what they are beginning to understand is how many there are and how long they have been moving. Space is vast. That's the reassurance most people reach for at this point. 100 million objects sounds terrifying until you consider that the Milky Way is 100,000 light years across, and most of that is empty. The math works out. The chance of one of these objects passing close enough to affect us is, by current astrophysical estimates, on the order of 1 in a few hundred million over the next 1 billion years. Those are comfortable odds. But here's what the comfortable framing leaves out. The odds do not require zero risk. They require low probability over human timescales. On the scale of the galaxy's history, on the scale of billions of years, this math has already played out for other solar systems, other planets, other worlds that never saw it coming. Jessica Liu, associate professor of astronomy at UC Berkeley and co-author on the Rogue Black Hole study, said that if a wandering black hole or neutron star passed anywhere close to our solar system, we would certainly see its effects on the orbits of the outer planets and comets in the Oort cloud. That would be the first sign. Not a flash of light, not a radiation burst, not anything dramatic. The first sign would be comets, objects in the distant Oort cloud at the very edge of our solar system, beginning to behave strangely. Their orbits, stable for billions of years, would be disturbed by a gravitational presence no one had detected. Then, the outer planets, Neptune and Uranus, their paths subtly different, their trajectories pulling in directions the models do not predict. And the object causing this? Still invisible. Its event horizon is only about 40 kilometers across, roughly the size of a city. 7 times the mass of the Sun compressed into something smaller than a metropolitan area, moving at 100,000 miles per hour. Dark against the dark. If that object were to pass within the orbital distance of Jupiter or Saturn, the consequences for Earth would not be subtle. The gravitational disruption at that range would be sufficient to alter Earth's orbit dramatically, potentially flinging us into the Sun, or ejecting us entirely from the solar system into perpetual frozen darkness. The geometry is unforgiving. A black hole moving at 50 kilometers per second could travel from the orbit of Pluto to the orbit of Earth in roughly 20 years. That's 20 years from the first strange comet to an altered world. On a cosmic scale, that's an eye blink. The true horror isn't that this is likely. It isn't. The true horror is that it's invisible, it's untracked, and the only early warning system we have is watching for stars to appear slightly out of position, the same method we used to find the first one, using 6 years of Hubble observations on a single event we happened to catch. 100 million objects. 1 confirmed. The rest moving in directions we haven't determined yet, toward destinations the universe has never bothered to announce. Here is what all of this actually means. The universe is not obligated to make its most dangerous things visible. It never has been. For billions of years, 100 million black holes have been moving through this galaxy, bending light, disturbing nothing, leaving no mark we could read until we built instruments sensitive enough to catch a 5 millisecond shift in a single star half a galaxy away. That is the instrument we built. That is what human curiosity looks like when it decides something is worth finding. And here is what the dread does not tell you. This is the beginning, not the end. NASA's Nancy Grace Roman Space Telescope, expected to launch around 2027, will survey the sky with 100 times Hubble's field of view at equivalent depth. Astronomers describe it as a machine for finding black hole microlensing events. It is expected to uncover thousands of microlensing events, many of them rogue black holes that have been crossing the galaxy for longer than life has existed on Earth. ESA's Gaia telescope is releasing additional lensing data from its billion-star map. The invisible galaxy is about to become visible. The galaxy isn't changing. We are. Every instrument we launch expands the boundary of what we can see in the dark. The 100 million wanderers have always been out there. Now, finally, we are learning to look for them. That star in Sagittarius dimmed and brightened in 2011, and it took 11 years to understand why. Somewhere, right now, another star is dimming. Another ghost is passing through. We don't know which star, we don't know which ghost, but we know the method, we know the instruments. And for the first time in human history, we are genuinely looking. The galaxy isn't empty. It never was. We just didn't know how to look until now. If that changes what you see when you look up tonight, subscribe, because we're just getting started.